this video, we are going to talk about how to make forecast errors and compare them with each other. Here's an example, and the same example that I gave you in my lecture. We have 8 quarters, and then actual tonnage unloaded data from quarter 1 to quarter 8. And the initial forecast data is given as 175 tons for both models. And let us first start with forecast values. So if you are using exponential smoothing method, then you can calculate like this. You start with equal sign and use the formula, which is right here. ft equals ft minus 1 plus alpha times at minus 1 minus ft minus 1. Here ft minus 1 is previous forecast, so you can simply click on the cell 175 and plus alpha is given here as 0.1, right? So you can type 0.1 times parentheses. At minus 1 is actual tonnage, so click on actual tonnage minus previous forecast, which is 175. So see, so this is your forecast value. Hit enter, and now you have forecast value for quarter 2. For the remainder of the cells, you can just copy that down, then it will automatically create your forecast values. You can do the same thing with model 2 with alpha value of 0.5. So here, start with the equal sign and ft minus 1, 175, plus alpha is now different, it's 0.5 times parenthesis actual demand 180 minus forecast, right? Hit enter again, copy that down like this, then you have forecast values for second model. Now the question is how to calculate the forecast errors and tell which one is better than the other. So let us first calculate forecast errors. Forecast error is defined as actual demand minus forecast value, and it's an absolute value. So I'm gonna use absolute function. So ABS, absolute value. Take absolute value between actual value minus the forecast value, right? And hit enter, copy it down like that. Then you now have calculated the absolute value of forecast errors for model 1. For model 2, do the same thing. We are going to use absolute function to get absolute values minus forecast. And then copy it down. Now you have forecast errors. Total is simply the summation of all the errors, so you can calculate that, and then just copy it down, copy to your right, then it automatically creates the sum of the forecast errors for model 2. Now our interest is in creating MAD value here. The MAD will be simply the sum of the forecast errors divided by n. So the sum of forecast errors and divided by the number of period, which is 8 quarters. So we just type 8, then 10.30. That's your MAD value for model 1. For model 2, we can do the same thing, equals sum of these divided by the period, and gives you 12.32. So now you can tell between 10.30 and 12.32, you want to choose this 10.30 because it's lower than the other one. So therefore, model 1 is more accurate model than model 2. Let us now calculate MSE. MSE is forecast error squared and divided by n. And we can use, in this case, sum squared function. So sum squared function. So SUM and parenthesis that divided by 8. And that gives you MSE 190. So as you can tell, 190 is much bigger than 10. It inflates error value so that we can easily tell what model has more errors, right? Do the same thing with this. So sum square of this and divided by 8 and 195.2. So they are close, but model 1 is better model because it produces less errors. Now lastly, let's talk about MAPE. It's more complicated to calculate MAP. As you can see in this formula, it's a lot more complicated. So I'm going to use more complex formula, and hopefully you will see and you will be able to use it. So equals, now I'm going to use the sum product function. Sum product function, what that does is it multiply these two columns and sum them up, and that's what the function does. So it says actual minus forecast, which is forecast error, divided by actual, right? So I have this forecast errors first, and then I'm going to divide it by actual tonnage. So to make it more expressive in Excel, I'm going to use power function and say these rows have to be divided by 1, so to the power of -1, right? Then that means it's divided. So that's what I expressed there. And then you have to multiply by 100 and divide it by number of periods, which is 8. And it produces 5.59%. And then the same thing you can do for the second model, which is Mape is sum product of this and divided by power that to -1 times 100 divided by 8, and that's 6.75. So between 5.59 and 6.75, you can obviously tell that model 1 is producing less error, therefore you want to choose 5.59. So if you have any models, you can create this kind of spreadsheet and calculate forecast errors and compare them together and find the best model. That's how to use Excel for forecasting errors. Thank you.